Hello, my name is Pini Dibask, and I'm a product manager for database monitoring solutions with Quest. Today, we will talk about how Forget Performance Investigator can help you solve the mystery behind execution plan changes. Let's talk about the agenda for today's session. We will start this session by reviewing Forget Performance Investigator. We will also discuss about execution plan changes. What are the main causes for execution plan changes and what is the impact of those changes? And then we will see how Foglight Performance Investigator can help you address those challenges and basically solve the mystery behind execution plan changes. So let's start with a quick overview of Forget for databases. Forget for databases is a heterogeneous solution for monitoring your entire environment across various database flavors from a single view. This solution supports SQL Server, Oracle, DB2, SAP ASC, MySQL, Postgres, MongoDB, and Cassandra. It's a 24 by 7 enterprise monitoring solution which allows you to effectively monitor your database environments. It features deep resource monitoring capabilities with powerful analysis toolset to quickly identify issues and proactively fix them before they become a real problem. This solution also offers comprehensive set of in-context and enterprise reports. It uses a remote agentless architecture which can basically monitor your environment remotely without installing anything locally on the monitored host or in the monitored database. So no schema objects are required in order to use the product. This solution can monitor the database from anywhere to anywhere. So we support customers who use both on-premise deployments, cloud deployments, and hybrid deployments. Forget has a very rich monitoring coverage for Oracle, SQL Server, and all the other database flavors. For example, here we can see in Oracle all the different aspects of high availability and disaster recovery solutions which are being monitored, such as DataGuard, real application clusters, Arman, etc. We also cover different storage aspects, including the automatic storage management, fast recovery area, redo logs, table spaces and data files, and of course objects. We support the 12c multi-tenant architecture and Exadata, so we're basically up to date with the recent technologies from both current and historical standpoints. Here we can see some of the main features that we cover in Forget for SQL Server. So for example, we monitor in-memory OLTP, always on, log shipping, tempdb, and basically you can name any feature in SQL Server and we support it. We also have a complete coverage of the BI suite. So we support SQL Server reporting services, integration services, and analysis services. Let's talk for a second about SQL PI. SQL PI stands for SQL Performance Investigator. It's analysis toolset for deep visibility into database performance. It's part of Forget for Oracle and SQL Server, meaning that it has a web-based interface with a simplified deployment. You don't need to install anything locally on the monitored hosts or the monitored databases. And SQL PI supports all database editions and configurations. So for example, whether you're running databases on-premise or in the cloud, whether you're using enterprise edition or standard editions, everything is basically supported by the product. Let's talk about SQL PI analysis toolset. The first feature that I would like to mention is dimensional workload analysis. It allows you to break the database activity into various dimensions, such as SQL statements, programs, users, machines, objects, files, disks, databases, etc. So for example, it allows you to visualize the activity of a specific dimension, for example, a specific user or a specific program at any point in time. It can also show you the activity for a combination of dimensions. For example, user sales that is connected to database HR and running a specific SQL statement 3 weeks ago or 5 months ago, basically at any point in time. So it's a very powerful tool to investigate the database workload activity and understand what is happening just by seeing visualization of the workload. Change tracking is also a very powerful tool because it allows you to correlate the database workload to the actual changes. It shows you a visualization and indications any point in time that we find a change in the database. It could be either object change, for example, index was dropped, table was modified, execution plan change. So every time we find a new execution plan for a specific SQL statement or batch, we show that on top of the workload chart. Configuration changes. So for example, every time we find any parameter which has been changed, or maybe a file configuration change, maybe a new data file was added to the database, we basically collect that as well. So it allows you to see a correlation between changes in database workload. For example, you can see that exactly at the same point in time where index was dropped, there was an increase in the I/O activity. So it allows you to understand what caused the increasing activity of the I/O. Compare tool is also powerful. It allows you to compare between instances and dimensions. So for example, I can compare between my production database to my testing database. I can also compare between one SQL statement to another, between users, between programs, machines, etc. It can also show you a comparison of various configuration parameters. So if you would like to ensure that your production and test environments are running with the same parameters, you can do that using Foglight Compare tool. The I/O analysis feature allows you to investigate I/O related activity for every dimension, including objects, files, and disks, so you can see the associated I/O statistics such as physical writes, block changes, physical reads, logical reads, etc., and also the associated I/O wait events. For example, it can show you also all the SQL statements that accessed a specific file, disks, object, which is very powerful if you would like to understand what are the hot objects in your environment. The lock analysis is very powerful if you would like to investigate lock activity. As we all know, performance issues which are a result of blocking locks could be common. It's very important for the application designers, the application developers to make sure that the code is written in a way that there are no concurrent access to the same shared resources, such as tables, indexes, partitions, because if that may happen, the database can wait due to blocking locks. So this tool allows you to see the lock trees of all the dimensions at any point in time. For example, you can see under a specific database who locked who, when, what was the duration of the lock, what was the SQL statement that was waiting for the lock, etc. Execution plan analysis. This is something that we will elaborate in today's presentation. It allows you to analyze execution plan by viewing all the historical execution plans, see various statistics about those execution plans, and even compare between different execution plans. Okay, so let's talk about execution plan changes. What are the main causes and impacts when there are execution plan changes in our database environments? Let's talk for a second about the basic concepts of execution plans. Execution plan is like a GPS of the database management system because it should really represent the best route possible to execute a particular SQL statement. In case that the execution plan, which was chosen by the query optimizer, is not the optimal one, it could have a tremendous impact on the overall database performance. In some cases where there are plan instability, there might be changes in the execution plans. And the reason for plan instability could be object modifications. For example, index was dropped. So a SQL statement that used to run so far by accessing a specific index in order to access the data, now it uses a full table scan, which obviously can impact the database performance. Another example, if the query optimizer statistics have changed. For example, the cardinality, which basically gives an estimation of how many rows should return by every step, every operation in the execution plan, is now changed. Now there is a new cardinality, and therefore the database optimizer could choose a new execution plan. As mentioned, the impact of plan changes on the database performance could be potentially huge. So let's see how to address this challenge, how to solve the mystery behind the execution plan changes using Foglight Performance Investigator. So what we see here is the change tracking feature, which allows you to see a breakdown of the workload activity and also all the associated changes on top of that. So it basically allows you to visualize the correlation between the database workload activity and the actual changes. So what you see here are several categories of changes: execution plan changes, configuration changes, schemas changes, system changes, and also user-defined changes. In the table in the bottom, we can see 4 new execution plans which were found, 2 jobs which have been modified, and 2 disks which have been created. Now I can filter the changes only to execution plans, so maybe I'm not interested to see all the other categories. I would like to focus only on new execution plans. We can see the 2 arrows that points to the places that basically could be a potential for an increased activity of workload, because we can see that immediately after those 2 changes, we saw an increase of the overall database workload. So let's drill down and understand what are those 2 execution plan changes. In the table at the bottom, we can see all the SQL statements which have the new execution plans. And it allows us basically to correlate between the changes in the actual workload by just understanding when were the changes and how could they impact the overall database performance by looking at the chart and by visualizing the differences in the activities. Once I was able to identify the plan changes, the new execution plans, I can further investigate those using plan analysis feature. Here we can see the execution plan analysis dashboard. It shows 3 tabs. The first tab is plan details. We can see all the operations, all the steps for the selected execution plan, as well as the associated statistics such as cost, CPU cost, I/O cost, and many other useful metrics. We also show aggregation of statistics per each one of the operations which appear in the execution plan. In this case, we can see that the hash join operation consumed 41% of the total execution plan cost. Same goes for objects. We can also show you aggregation of statistics per each one of the objects which appears in the execution plan. In this case, we have 2 indexes. Each one of them consumed 50% of the total execution plan cost. It is possible to click on the object and then see a pop-up with additional information. In this case, we can see information such as the creation time of the object, the last analyzed, which is very useful because it can show you when was the last time that statistics were gathered on that object, which could be a potential reason for execution plan change. We can also see the last DDL time and many other metrics such as the clustering factor, access count, the size of the object, the number of distinct keys, number of blocks, number of leaf blocks, number of rows, the depth of the index, etc. If you click on the object and it's a table, you will see additional information that is relevant only for tables. But in this case, we see an example of metrics for indexes. The way Foglight collects execution plans information is by running every minute and collecting the top 5 unique execution plans directly from the database memory cache. Foglight stores the execution plans in our embedded repository, which allows you to view historical execution plans information even from a few years ago. If you would like to manually generate execution plans so you can later view them using Foglight, you can do that by clicking on the Generate Plan button. It will show you a pop-up which requires you to provide credentials such as username and password in order for us to generate a manual execution plan. This could be very useful in cases where you want to view an updated execution plan. Maybe you just gathered new object statistics and you would like to see if there is any change in the execution plan. You can also choose execution plan for a particular SQL statement by clicking on the date of the execution plan, and then you will see a list of all the execution plans that we collected, or execution plans that you manually generated. So in this case, we can see the type column, the second column, which could be either generated or actual. If it's generated, you can know that this is an execution plan that a Foglight user manually generated. And if it's actual, it means that Foglight was able to collect the execution plan information directly from the database memory cache. You can also compare between historical execution plans. The way you can do that is by clicking on the Compare Plans button. The Compare Plans button will open a pop-up that shows two execution plans that you can compare with. We also highlight the operation changes, so we can see that the left execution plan uses table access full operation, whereas the other execution plan in the right section of the pop-up uses index fast full scan. If you would like to learn more about the product, feel free to visit our website, Foglight for Databases. We also offer a free web-based course, which is available on ToadWorld, our database community website. Thank you for listening to the second episode in this webcast series.